I'm not going to justify anything in this video, so this is probably going to be the worst video I'm ever going to make. But that's okay. I think it's good that I make this video now when I only have 10 subscribers so that uh, I can get out the things I want to talk about without much scrutiny. But it's okay. I only make these videos for my friend, maybe my brother, and the one guy who comments on all my videos, so I'm happy with that. The topic is technologies that are going to lead to ASI. So, what is ASI? I'm not even going to get into that, but you might hear me reference in other videos. I think there's going to be a step change, or not even that. I think there's going to need to be a step change in order to talk about the sort of utopian or perhaps doomer scenarios that are possible. By the way, I have terrible allergies right now, so I kind of look like shit. But what I'm talking about is that step change where right now we're working with models that are based on uh, transformers, backpropagation, kind of conventionally known techniques. Um, what are some sort of things that are going to be innovations where if we explore that space of possibility, we're going to discover something that just unlocks artificial superintelligence? And I'm making this video now because I want to be able to point back and say, look, I told you so. Because I know what it's going to be. I can't explain why, I just know what it's going to be. And 5 years from now, when we're all dead because of AI, I'm going to point back to this video in my corpse and say, look, I made a video saying it was this. In reality, I'm going to predict it's like 10 different things. So I'm going to be right no matter what, because it's probably going to be one of those 10, or none, in which case that will be funny. But okay, what are those things? Number one, I think we're going to see a comeback of recurrent neural networks. So the neural networks that are kind of popular right now are you have these discrete layers, and each layer, its activations only flow into the subsequent layer, and you have layers of dimensions kind of architected by humans, and each layer is distinct, so they each have their own sets of weights and biases, and there's such a thing as recurrent neural networks, but the way that works is in order to get those to work, in order to do backpropagation on those, you need to sort of unwind the whole neural network to treat it as if there were multiple layers so you can backpropagate on it. I think neither of those things really are how the human mind works. So when I say recurrent, I mean something much more analogous to this sort of mesh, which is the brain, all these neurons pointing every which way. We don't have activations flowing through layer by layer. What we have is this slosh of like a sea of activations that are flowing one way, another way, back and forth. They can hit the same neuron twice, and so on and so on. One philosopher who has been influential in helping me understand why mechanistically the recurrent nature of the brain is helpful for creating consciousness is Anil Seth, if consciousness is something you care about. But even before that, I think it was like on some level intuitively obvious to me. I don't want to say obvious, but it made sense to me that um, the sort of complicated, decentralized, um, complex system of a network like the human brain that would create the requisite level of complexity and weird assortedness that would allow for the emergence of consciousness and that sort of a higher level intuition that we understand humans are capable of. The next thing that is going to take over the world is continuous learning. And partially this is obvious. It's not that people don't want to create continuous learning, it's that they can't because of, again, the architecture of our current systems. It sets this fixed context length, right? And people try to extend that. I have the one video where I talk about um, how I think compaction is bad and how I think organizing the context correctly in an algorithmic process will address that. That is sort of on the level of what I'm talking about. But on a broader level, is there some way of um, superseding this problem altogether, right? Because we know that um, like humans don't really have this problem. We are readily capable of continuous learning. Um, is that because we have like a better version of compaction, or is it something more fundamental? But whatever it is, I think that once we solve for this, getting continuous learning right, if you could somehow one-shot that, then that would be the equivalent almost of the Froome takeoff scenario that people predict that recursive self-improvement would be. Another basic thing is that I think that the building blocks of the next step change of models, it's not going to be some galaxy brain complex thing. It's going to be bitter lesson pilled. It's going to be minimalist, or maybe a better word would be parsimonious. It's going to be deconstructing the building blocks of intelligence even more than we already have done with transformers and current architectures. Another conclusion that jumps out at you is that a big step change of intelligence is going to have to come from reinforcement learning. And we can see this historically, all the cases where you get superhuman AI, like chess playing robots. Chess playing robots are superhuman AI, or AI that plays some or other video game. That's going to be superhuman AI. Whereas AI that tries to emulate humans, like AI that writes essays better than humans, AI can write essays maybe better than 90% of school students, but it can't write essays better than 100% of school students. So it's not superhuman AI because it's trying to emulate sort of the typical human, right? Reinforcement learning doesn't have this problem. When you set up a sandbox environment where it can just try a bunch of different things and find strategies humans never would have thought of, like chess playing AIs, that is superhuman. So I think to cross the human threshold, it's going to rely on reinforcement learning. And maybe I could talk about this a little bit more once I make a video giving my thoughts on doomerism and whether I think there will be the end of the world, because I've been thinking about this for quite a bit. Another thing that I think is going to be related to ASI, the innovation for ASI, is going to be cellular automata. I'm not going to justify it, but I think there's going to be some sort of correspondence. Like the person to build the next ASI, that the ASI algorithm, that person is going to have a background in like studying cellular automata, or the first paper is going to take inspiration from cellular automata in some way. I don't know. But personally, I've worked with cellular automata in the past. If anything, this has the rare property of being one of the fields of computer science math that I think is actually more interesting than AI. So between AI and cellular automata, if I could pick one to study, I don't know. Like AI is having its day, but I think cellular automata is in some ways more interesting. There is another type of algorithm that has the same property. This is evolutionary algorithms. I've worked with evolutionary algorithms a lot, and I shouldn't say I worked with it. I've been a hobbyist on evolutionary algorithms for many years, and I think evolutionary algorithms are, if anything, more interesting than AI itself. So I don't know. It would be a shame if we somehow got to AI without either taking inspiration from or incorporating evolutionary algorithms even more than we have already. My interest in evolutionary algorithms, believe it or not, it comes from middle school, where I went to a middle school that was a little weird. I had one student who I was friends with who introduced me to maybe game isn't the right word. He showed me Boxcar 2D, where if you look, you can still go to it now. And from modern day perspective, it seems very rudimentary and kind of lame. But the concept of this sort of thing, it just blew my mind at the time. It just intercepted with so many interests I also had already. And I would go on YouTube, look up evolutionary algorithms, anything that anyone had posted. There wasn't a lot of content back then, but it's held my interest for a long time. This intercepts with some of the things I've talked about already, like how I think the architecture will be different with recurrent neural networks or evolutionary algorithms creating this. But one thing that I think is going to be different is right now we have these very human driven architectures. Human decides based on the hardware constraints how many attention heads are we going to set, how many layers, and so on, the dimensionality, I think we're going to move towards away from anything human driven and further as time goes on towards a sort of self-organizing structure over hard-coded rules. Obviously, you have to balance that with also needing to comply with the hardware restrictions, right? To take advantage not only of the material reality of what hardware we have available, but also take advantage of the next generation of hardware innovations around GPUs and so forth. So it's going to have to incorporate that. And I'm not sure how to balance that with wanting to make it open-ended as possible. If you think about how learning happens for humans, there's different modes of it. Obviously, there's like working memory versus long-term memory. But for living things, there's also the distinction between like memory itself versus affordances based on you're born with this amount of knowledge, you're born with a certain level of spatial recognition. And how much of our knowledge comes from evolution, from selective, evolutionary selection versus the lifetime learning. And the capacity for lifetime learning in itself is something that was selected for by evolution. So how much do you, or where do you place evolution in that? Also, evolution needs to go through this bottleneck of the DNA sequence, which is a compressed state, right? Those DNA amino acids, that does not have all of the details of what it will become, but it has the building blocks for creating what it will become. So it's like a code that's a compressed version of what it will become. Like how I would describe it is, if you look at a spider's web, that spider's web, because spiders have ingrained the ability to build webs, and they have that complex shape, but where is that in the DNA? It has to be somewhere from a pattern-based perspective in the DNA, although not in the form of a web. It's going to be in the form of the spider needs to do this at this point. The spider needs to do that at that point. It's multiple levels removed. The DNA creates the proteins which create the body of the spider, and then the body of the spider, it has these behaviors, and it creates spider silk, and then it takes a series of moves. It moves here, there, and at the end, you get the spider's web. So if you trace it back enough, there's something in the DNA that results in that outcome, but not the full end image that you get. So I think there has to be some inspiration from that of how do we build these enormously complex structures out of very parsimonious building blocks. Not to say DNA is parsimonious, but the fact that it is this sort of other substrate that you have to compress the information into, I think that is going to be something you build upon. I have a final prediction about how I think the technology will come about. I think that a disproportionate amount of the engineering work that goes into this, from a standpoint of literally creating the code, but also having the ideas, putting everything together, it's going to come from a single, highly dedicated individual. The sort of startup, scrappy mentality of like every tech visionary. What if it could just be one guy who goes through and makes everything? And I have a sort of intuition for the kinds of things which I think are better done by large organizations versus the kinds of things that are done by one-man teams, two-man teams, excuse me. It is undeniably true that one-man teams and two-man teams can achieve just extraordinary things by themselves. Like if you look at video games that were made by large teams, those are AAA games, those are great. But also you have indie games which are made by one or two people, and those are also great. And they use assets that are pulled but from more people, obviously. They're not doing it like completely from scratch, but the fact that it was driven by one or two people and that it works so well nonetheless, that is a thing that can happen. Like Minecraft originally had one developer for a long time. You see this in a lot of things. I think even in the story of the modern wave of AI, how much of the initial like GPT-3, GPT-2 was from Ilya Sutskever or from influences from Andrei Karpathy. I think a single individual can have enormous influence here, especially based on how I'm characterizing it, where I think it will be small, decomposed, like parsimonious building blocks that we'll make this out of.